welcome students to the NPTEL MOOC module on handling healthcare survey data. After discussing the previous class on normalizing data set, I have said and I have mentioned that there are possibilities of missing values. Missing values have strong role in analysis of big data or in large scale data set. There are huge possibility of generating missing values because of many reasons. If missing values are there, that may create some inconsistency in our result, and those has to be dealt appropriately instead of simply avoiding. So, let us get started with the discussion of missing values. In statistics, missing data or missing values often occur when no data value is stored for the variable in an observation. This situation mostly occur as a result of manual data entry procedures, equipment errors and incorrect measurements. So, there are three important reasons by which we get into or get the missing information or missing values, like equipment errors or incorrect measurements are most important. Sometimes in the schedule we have wrong procedures followed, in the question sequencings are not followed, or the questions are asked to a wrong person, or even if it is asked to the person might be reluctant to answer. Okay. So, there are possibilities of missing entries or missing values. So, maybe the equipment generate missing values as well. So, that is very much possible. In this sample data set, there are question marks given. This indicates some missing points. Coming to the missing data in a in the data sets, this is, as I mentioned, that it is quite common in everyday research in the real data set, and this is caused by different factors, such as high cost involved in measuring variables, failure of sensors, reluctance of respondents in answering certain questions, and ill designed questionnaire. Okay. So, the problems of missing data are of it reduces statistical power. So, statistical power or power of the test, you might have heard about it, okay, accepting or non accepting a null hypothesis, or if your say value is going to be significant or not. These are various discussion we usually deal with in our hypothesis testing. Statistical power roughly means probability that the test will reject the null hypothesis when it is actually false. Even if it is false, still it is rejecting a null hypothesis. So, it is not like your type 1 error rejecting a null hypothesis when it is true. It is actually false, but still it is rejecting a null hypothesis. Lost data, like the problems of missing data is like lost data. Those lost data can, or missing data or lost data can cause bias in the estimation of parameters. The missing data may result in less representativeness of your sample, and this missing data is generated due to complications in handling and analyzing the data. This has huge connection with the loss of efficiency in your results or in your data. So, coming to the missing data, once again we are addressing through three important types. The one is called missing completely at random. In short, we write it as as per the existing studies, they refer it as MCR. Then missing at random and missing not at random. So, MAR or MNR is mentioned. So, first one is missing completely at random. That means the data are collected and observed arbitrarily, and the data collected data does not depend on any other variable of the data set. If simply arbitrarily is collected, but it is actually not dependent on any other variable of the data set. The probability that the data are missing is not related to either the specific value which is supposed to be obtained or the set of observed response which is required for the analysis. data are missing by design. We have already said there might be various possible design in the data set in the survey. So, through the design it is possible that there will be complete randomness in the analysis or in the collection of the data. Data are missing by design because of an equipment failure or because the sample lost in transit or technically unsatisfactory. Such data are regarded as missing completely at random. Missing completed data at random basically MCR data analysis remains unbiased, but power may be lost in the design. Okay, so data may be unbiased, it might give near about your mean value of the population of its estimates might give you the mean value of the estimates, but the power, that is the power basically taking any inferential statistics out of it may not have enough confidence. This power may be lost in the design. So, missing at random, another type of missing value tracking is that probability of an instance having a missing value for an attribute may depend on the known values, okay, but not on the values of missing data itself. So, missingness can only be explained by variables that are fully observed, whereas those are partially observed cannot be cannot be responsible for missingness in others. For example, in this case women in the population are more likely to likely not to reveal their age. Therefore, percentage of missing data among female individuals will be very high, and this is also possible at random. Third type is of missing not at random. So, when data either not of either of MCR or I mean not either of MCR or MAR, it is possible to have non MNAR. Missingness depends on another partially observed variable. Situation in which the missingness depends on the actual value of missing data. The probability of an instance having a missing value for an attribute could depend on the value of that attribute. Okay. Now, missing values and it's the approach to handle how to handle missing values, that is quite important in research. One is called deletion method. Once you know that your cases are or your variables are missing, you can simply delete. Okay. Subject to you should have huge data on your pool or on your record, that may not create much difference. Second approach is called listwise deletion. Then third one is called variable deletion. You can also follow pairwise deletion. You can also follow that, but at this moment we are presenting listwise deletion and variable deletion, since that one is not that important. Okay. We are going to deal with that in detail now. Another important technique, most important and most frequently used, is called imputation technique, imputation method. That might be single imputation, that might be multiple imputation. So, most frequently in large data set, in research, in detailed research analysis, multiple imputation is applied. But single imputation, like you can go with mean or mode imputations, then conditional mean imputations, then regression imputations, and last observation carried forward based imputation. Okay, so these are now discussed. First case is called listwise deletion. Listwise deletion, when you know that these lists are having certain missing values, so better to, like if the in the example data set here, if the serial number 2, 4 and 9 and 8, 2, 4 and 8, there are some missing values in any of the entries, that might lead to some possibility of bias estimates, or even if it is not bias estimate, if it is the power of the test is compromised. So, better to delete complete list. All right. Whereas, in case of pair, you need not delete all the list together, you can just try to check which two pairs are actually missing. So, those two pair variable you can also delete instead of deleting entire variables. So, it depends upon how you are handling and how you are looking at. So, in this case one aspect one bench line is mentioned, that is a good method. Listwise deletion method is good when the proportion of missing data is less than 15%. There are advantages. It can be used for any type of statistical analysis. No special computations are required. The parameters estimations are unbiased, and the standard errors are appropriate compared to original data. So, these are the advantages we just discussed. So, that is the reason why this is most used technique. One disadvantage is that this may remove a considerable fraction of data, since we are actually deleting the entire observation and its details of the particular case. Second one is called variable deletion. Variable deletion involves what once you know that your variable one variable is not that important to you and it has missing value, or number of missing values. Okay, out of 3 we have a gender, gender is having a missing value, and when I know that this gender variable is not that important in my analysis, that variable could be deleted or dropped. So, variable deletion involve, whereas in case of group wise deletion you need to, or pair wise you have to find out which 2 pairs actually is not that important, you could have also deleted that. We are not discussing much on that, we are simply discussing the one which is most frequently used. So, there are advantages like this makes sense when a lot of missing values in a variable, and if the variable is of relatively less important, and there are disadvantages like since you are losing an information, a loss of information is there, your model might be constructed with less variability or less observation or less variables. The next aspect is we are highlighting with the application of stata. We are not operating, we have, since they are very easy, and we will be guiding in all those details in our regression analysis, how to deal with the missing values also. But at this moment we are just giving you the snapshot from our own stata operation, like as per our NSA 7/5 round data. This in the data in the browse window you can easily check which are missing. Okay, here in the dot represents missing. Stata highlights the missing data with the entry as dot. Okay. So, stata reads missing as dot as a value greater than any number. So, if like suppose you are giving a command which is, suppose you wanted to get in stata like your data should be caveated within a range, you wanted to, suppose in expenditure you wanted to highlight the expenditure which are greater than 1000 in the data. So, below 1000 whichever are there, that will be displaying with a dot, all right. So, it depends upon how you are giving the command, but in general stata gives dot as the missing value information. So, now I am explaining here about about including multiple variables, that once it is applied in your list of analysis, if there are so many variables, it automatically finally comes with a fine observation with missing with avoiding the missing values. Like for example, you have different entries here, person's ID, expenditure, level of care, we have different observations 43,000, 41,000, 31,000 something. But finally, in the model, in the mean estimation, even a simple model, while including all these 3, it is not considering the entire one, it is only considering the one which has all the information. It might have deleted those missing entries. Okay. So, finally, you are left with the observation in a net where the mean could be derived. Alright. So, this is what the power of the missing value. How missing value, if you have corrected, like it seems as if there are some missing values out of these 3 variables. If you have corrected, this number of observation could have been increased. Okay. Now coming to mean or mode substitution based approach to deal with the missing values. So, one is called you can replace missing values with sample mean or mode. Sample mean or mode, on the first variable x1, x2 and x3, we either we replace this missing value with its mean value, okay, or anywhere with the mode value, depending upon which type of variable you are considering. If it is a scaled variable, if it is in nominal scale, that means it is suggested to go with the replacement with mean value. Okay. If it is not a scale variable, if it is it is categorical variable, qualitative variable, in that case it is suggested to go with a mode replacement. Mode replacement in that missing values. This has advantage, like this can use complete case analysis method, and there are disadvantages as well. This will reduce variability and weakens covariance and correlation estimates in the data, because it ignores relationship between variables. So, of course, since you are replacing with something, there are possibility of weakening of its correlation or covariance. Second one is even little better, with little co-research, like we have in the category of gender instead of, but the like here these are all male. Okay. So, but there are certain missing entries in variable x1 and x2. What you do, instead of entire averaging this, you could have actually average out with its females, and you could have averaged out the value with this male information. So, replace missing values with values of the relevant mean for a relevant subgroup is very important. So, this is actually carrying this average, or even as per the requirement it could be also the mode value. Okay. So, instead of entire, you are actually following the subset of it and exactly replacing it. Now, it is very interesting, you can just take a snapshot, or you can follow the video very carefully, and accordingly you can open the Stata window, and accordingly click on this, you go to data, okay. Then you click on, out of all those options, you click on this create or change data, okay. And there will be drop down menus, further drop downs, like out of all those things you just click this other variable transformation commands, and then you have to select this, like change missing values to numeric. Okay, like you have missing values, with the command only you can replace those missing values to numeric. This is what is very important, and it can be dealt with Stata. Like once you have understood your distribution, what exactly which value you are going to replace. Let us you are replacing by mean. How to know that? You have to go with the summary statistics, either with SUMM or simply with SUM. Okay, SUM with this variable, with that variable it will be displayed with mean, standard deviation, mean, minimum value and maximum value. So, if mean value is of this is what we can able to replace. Once you click on the previous window here on this, it will be displaying with this type of window, and there you will simply enter the value, that is 2.71 or the entire 2.714885, that will be replacing all those missing values will be replaced. Okay. So, usually in the Stata comes up with or most of the database comes up with the missing entries like 9, 98, 999 or 999, or they will instruct it what exactly they have entered. Then you have to submit it, it will be replacing. Next one is your regression imputation. Regression imputation, like this is most important. I suggest everyone to please take a note of it instead of just randomly getting a result without taking care of missing values. It is essential. So, regression imputation, what does this mean? This means you are this replaces missing values with predicted score. Regression gives predicted values, as we all know, okay, from a regression equation. This is like a simple linear regression equation. It is constant value, it is coefficients, okay. Whether it is standardized coefficient or non-standardized coefficient, normalized coefficient or not, you need to check it very carefully. If beta, as I told you, these are beta values, beta, standardized beta or non-standardized beta, we will discuss sometimes in some of our lectures. I have already guided you before that once you have filtered your data set very clearly, you have dealt with certain all the variables with its normalized scale, all your data is scale free. Okay. After that, if you are running your regression, now your coefficient is coming out to be standardized coefficient instead of non-standardized one. Okay. What are the advantage of this regression imputation? This is basically the expected value we are replacing. Okay. How is it? Like advantage is that we are using information from the observed data. Based on the observed, there are predicted values. Disadvantage is that sometimes it overestimates or overestimate the model fit and the correlation estimates as well, and this weakens the variance. Since you are getting a figure which is close approximate to other entries, so obviously this will reduce the variance, and that may not be though good in interpreting result, but may not be reflecting the exact data. Since data is completely missing, it is better to take this instead of avoiding. In data, how we do it actually, suppose in the data this is the missing value, this is the missing value. How to do it? We have to simply run the regression, okay, run the regression of those 4 variables, 3 variables, let it be as regress, level of care, expenditure, nature of element as per our 75th round, a sample estimates we have given here in the data. Now, you can also check some of those basic information like observation, its F statistics, its p value. It seems that your model is perfectly fit, though the R square value is not that good, since we have shown here as a sample data, very small data set. So, it might throw with a very small R square value. Usually small R square value cases where your model is not perfectly fit. But anyway, this is simply a sample data set. I wanted to just mention that once you run the regression, you got with your coefficients and most importantly your constant value and other 2 coefficients. So, your constant value is this and other beta 1 and beta 2 is given here. So, this is all about your estimate. So, 2.78 is here. This is the one 2.87, okay, 871597, and plus is positive sign is given against to expenditure plus this one times your 45. What is this 45? This is your 45. Okay, here it is. This is the one. So and 4 is here. All right, and 45 is here. This is what we are using, and based on this we have got a predicted value, that is 2.85. This 2.85 we can use it here over here. Okay. So, likewise this we can also do it for all other entries, all other missing values, and it is going to be very robust. So, last observation carried forward another method. Once you know that your last observation is having a value and that is going to be very relevant for your analysis, that one can be carried. Okay, that like the last observation, this is basically here as it imputes the missing values as a value on the same outcome the most recent time it was observed. Okay. So, once you have observed previous time, that one could be actually entered. So, take basically you can also take the average of x 1 and x 2, and once that is close to the value, that value could be entered as well. Last couple of slides are there just to guide you and to give you a complete catch of understanding missing values. We have called multiple imputation, like it considers with impute, analyze, pooling, and simultaneously we are leading with a missing a value that will be filled in the missing data. So, data is filled in with imputed values using specified regression model. This is what we have already said earlier. This step is repeated m times because of the number of missing values, resulting in a separate data set each time. Okay. And then you will analyze and perform within each data set, and based on that we will again pool those new findings or new predicted values. Based on that we can pool it into one estimate. Okay. This is in the chart you can easily see, like if data set has many missing values, we will analyze categorically one by one. Okay. Then we get number of imputed data sets, and we will analyze through regression, and this coefficient will be derived and that will be considered. And why we are pooling this? We will actually pool or append those extra information that we have derived based on our new data. Once we pool to the each corresponding data entries, then we have generated a new data set, and based on that we will get our final estimate. Okay. So, this is what is called multiple imputation. Since every stages we are actually having our analysis done, and one advantage is that the variability is actually well captured. It is more accurate than that of the simple imputation, simple regression imputation. Since the entries are going to be different, instead of a single regression we are getting with different models every time, different regression every time, and getting a pool of data, and based on that either you can again take another steps to moderate it and get the missing values. This considers variables due to sampling and variability due to its multiple steps of imputation. There are disadvantages, like it is very tough to deal with because it has number of steps involved. It is in fact quite cumbersome in terms of coding and its entering. So, room for error is in fact higher since you are dealing with the approach multiple times. So, these are all for today. I think I have explained. So, you can combine the last lecture and today's lecture while you are following. I am sure it is going to fill up the gap so far the existing research is concerned, and these are all fine tuning or beautifying your research. Okay, or your research is going to be having very strong base. Once you are writing your papers, once you are generating your final data set and deriving results and interpreting, it is going to be well accepted among the by the reviewers or in the editorial board. Therefore, I suggest that you please follow, and accordingly you go for the handling missing values for final analysis. I hope it is understood, and I am sure you will have certain difficulties, and those could be dealt in our doubt class or in our live session. Okay. So, with this I think I must say thank you because of your presence. You may also get your query solved through my TA involved in this program. They are Mr. Kamal and Mr. Milind. Okay. So, their details will be also available through the NPTEL office. You may connect to them as well. So, let us stop here then. Thank you.